Hello, everyone, and welcome to our educational session. My name is Paul Arsov, and I'm the founder of the Decentralized Web project. I'm going to talk about this project and several other projects in the end of this presentation. But the topic today is the perfect storm, legacy code and the exploits of actually intelligent AI. The topic touches on development and specifically development in the area of artificial intelligence and also in touches on the rapid advancement of the field of artificial intelligence itself. Um, so we are heading towards a perfect storm on the cybersecurity horizon. Picture this, you are standing in the vast digital wasteland where mountains of tangled code stretch to horizon, each strand writing with the kind of organic chaos that world made Lovecraft whip. Now imagine that lurking in the shadows are predators equipped with artificial intelligence so sophisticated that they can spot weaknesses in this mess of code faster than we can create them. And we're creating them with an unprecedented rate because um, we're handled and handed the keys to our code factories um, to other AIs, all in the name of faster, cheaper, and more. Welcome to the today's world where three converging forces are creating what may charitably be called a cybersecurity apocalypse. The first one is the growing mountain of spaghetti legacy code, decades of accumulated technical debt that would make an Italian grandmother disown us. The second um, trait of this apocalypse is the razor's edge of offensive AI, artificial intelligence that is getting frighteningly good at finding and exploiting our digital fumbles and weaknesses in code. And the third trait is the business imperative of AI-driven mass production, corporate pressure to churn out code at machine speed with minimal human oversight. The thesis is simple, if terrifying. The synergy between neglected tangled code, whose volumes is exploding thanks to AI-driven development pressure and sophisticated offensive AI capabilities. And this is creating a new exponentially growing level of risk that demands a fundamental shift in how we approach software development and cybersecurity. In other words, we're not just fighting yesterday's war with tomorrow's weapons, we're actually arming our enemies while blindfolding, um, blindfolding ourselves. Let's start with the basics, shall we? Legacy code is any code that works but that nobody wants to touch. Rather, like that mysterious casserole in the back of your refrigerator that is technically still food but poses an existential question about the nature of decay. Spaghetti code is what happens when that casserole develops sentience and starts making architectural decisions. Traditionally, spaghetti code emerged through the natural entropy of software development, rushed deadlines, changed requirements, developer turnover, and the universal human tendency to solve problems with increasingly creative interpretation of temporary solutions. It is the digital equivalent of urban sprawl. Each addition seemed reasonable at the time, but the cumulative effect resembles something designed by a committee of caffeinated squirrels. But here's where our story makes a decidedly modern turn. Enter the business mandate of faster, cheaper, more. The holy trinity of corporate optimization that treats software development like a factory assembling line. In this brave new world, shall we name it, um, AI isn't just a tool, it is the entire production floor, churning out code with the mechanical enthusiasm of Victorian textile mill. The pressure is intoxicatingly intoxicating with its simplicity. Why employ expensive humans who need sleep, coffee breaks, and the occasional existential crisis when you can have AI generate vast quantities of seemingly functional code? The mathematics appear compelling until you realize that we are essentially um, automated the creation of technical depth at an industrial scale. Consider the implications. AI can produce thousands of lines of code in the time it takes a human developer to argue about proper variable naming, naming conventions. But here is the rub. That AI is trained on a collective programming wisdom of humanity, which includes every hack, uh, botch, and to fix this later comment ever committed to a repository. It's like teaching someone to cook by showing them every kitchen disaster video on YouTube. The result is code that often works hooray, but carries with it the accumulated sins of every developer who ever thought, I will clean this up in the next sprint. We're generating unprecedented volumes of potentially buggy, poorly understood, minimally supervised code. It's rather like having a brilliant but slightly drunk copyist reproducing the Library of Alexandria. Technically impressive, practically terrifying. The most insidious aspect, this AI-generated code often looks reasonably competent at first glance. It follows patterns, implements functionally, and generally appears to know what's what it is doing. It's only when you dig deeper that you discover it's built like a house of cards in a wind tunnel, structurally ambitious but fundamentally unsound. And unlike human-generated spaghetti, which at least carries the DNA of conscious decision making, however misguided, AI-generated complexity can emerge from patterns that no human fully understands. We're not just inheriting technical depth, we're manufacturing it at a machine speed. Every time and every line of code is a potential vulnerability, a fact that keeps security professionals awake at night and sustained by increasingly exotic coffee plants. When you have a code base that resembles um, MC Escher painting crossed with a bowl of linguine, then mathematics become genuinely frightening. Traditional spaghetti code carries attack surface through several delightfully predictable mechanisms. The first one is for forgotten modules that lurk in the system like digital ghosts, unpatched and unloved. The second one is undocumented APIs that function as secret doors for anyone clever enough to find them. And the third one is inconsistent security standards across different system components. Imagine a castle where some walls are made of stone and others of paper. And the last one is complex interdependencies that make any change feel like diffusing a bomb while blindfolded. But here is where AI-driven development transforms manageable nightmare of traditional legacy code into something that would make Dante update his circles of hell. When you are generating code at machine speed through AI, the sheer volume makes comprehensive human oversight not just difficult but practically impossible. Consider that sobering reality. A single AI system can generate more code in a day than a human developer produces in months. If even a small percentage of that code contains vulnerabilities, and statistics suggest it will, you are not just increasing your attack surface, you are creating attacked continent-size surfaces. The traditional security model assumed that humans would be the primary architects of systems with all the natural bottlenecks that human limitations provide. When you remove these bottlenecks, namely human generated code speed, uh, without replacing them with equivalent oversight mechanisms, you don't just scale up your capabilities, you scale up your exposure exponentially. Modern software development relies heavily on external libraries and dependencies, a practice that works brilliantly until it doesn't. In the world of AI-generated spaghetti code, this becomes practically problematic because AI tends to enthusiastically embrace um, whatever patterns that it learned, including potentially dangerous dependency relationships. Imagine, if you will, a system where every component depends on several others, which in turn depends on others, and so on and so on, creating a web of relationships so complex that changing one element could theoretically crush your dishwasher. Now imagine that this web was largely constructed by an AI that learned its architecture principles from studying existing code bases, including all the questionable decisions that this code base contained. Um, While we have been busy industrializing code production, the other side of the equation hasn't been idle. Offensive AI, artificial intelligence designed to identify and exploit vulnerabilities, has been evolving with the focused intensity of a particularly determined species of digital predator. Modern offensive AI systems can perform reconnaissance at scales that would make traditional hackers weep with envy. They can scan millions of endpoints, analyze patterns across vast code bases, and identify potential vulnerabilities faster than human defenders can catalog them, let alone patch them. But here's where it gets genuinely unsettling. These systems are learning. They are analyzing successful attack patterns, understanding defensive responses, and adapting their strategies in real time. It's rather like facing an opponent who not only never sleeps but gets smarter every time you play against them. And with this said, I'm ending this presentation, and this is just part one of this presentation. Stay tuned for part two of this presentation, where we're going to look at offensive AI capabilities and what we humans could do to mitigate and resolve these vulnerabilities, at least temporary, in this perfect storm which is brewing between generating more AI code and the offensive capability of AI itself. And with this said, I'm coming back to the beginning of this presentation when I told you that my name is Paul Arsov and I'm the founder of the Decentralized Web project and several other projects that we did release. But first, the Decentralized Web project built a decentralized communication advertising platform. As I just mentioned, it is monetized through advertising. The project has its own blockchain instance, and this blockchain instance generates tokens, and with these tokens we reward people who come to our decentralized web platform and become users on this decentralized web project. And it also, the project also rewards users of the decentralized web platform with tokens for viewing advertising. And the way of advertising is very permissive. You, the user, uh, have to click a button to start viewing advertising, and then you have to view advertising one page after another page by clicking a button to advance to next page and to next page and again. And for this very permissive viewing of advertising, we reward our users with tokens, and also we reward our users with tokens for inviting other people to join our decentralized web project. With this said, I'd like to tell you the name and the URL of this project. It is decentralizedweb.org. Decentralized and web, these are two words, and they are typed all together. Decentralized web. Then there is dot, and it ends with org. With this said, I like to go to the next project that we built and released, and this project built marketplace and collection of non-fungible tokens or NFTs based on three-dimensional objects. With 3D objects, we have to have a special engine which reads the 3D object file, and then it displays this 3D object file in a computer screen. Traditionally, the creators of 3D objects, they used standard software, and currently there are two very popular choices. One of them is a game engine called Unity, and the other one is a game engine called Unreal. But from the very beginning of our 3D NFT project, we decided to build our own 3D software engine, and what it does, it opens a window on a computer screen. Then it reads the file of the 3D NFT object, and then it displays the 3D NFT object file in the window it opened, and then our 3D software engine starts animating the 3D NFT in a way of moving it in a random fashion around the window it did open. But in addition to these initial and basic capabilities, our 3D NFT software engine has multiple additional capabilities. The first additional capability of our 3D NFTs is the capability of speaking. Our 3D NFTs can speak in one of three different voices, namely a male voice, a female voice, or a whisper kind of a voice. In addition to the three basic voices, there are three different flavors of voices. A voice can be spoken either in a normal speed fashion, or in a fast speed fashion, or in a slow speed fashion. The next additional and important capability of our 3D NFTs is the capability of voice recognition. You can ask if you have a 3D NFT being animated and moving in a random fashion around the window, then you can issue your very first voice command to the 3D NFT to stop moving. And then the 3D NFT is going to stand still and stop moving. You can issue following voice commands to the 3D NFT to move left, move right, move up, move down, zoom in, zoom out, rotate. And then the 3D NFT is going to fulfill each one of these separate voice commands, and move left, then move right, move up, then move down, zoom in, then zoom out, and start rotating. The next additionally important capability of our 3D NFTs is the capability of them having a basic artificial intelligence. Wow, really wow. You can ask the 3D NFT to describe something. For example, describe Web3, or describe decentralization, or describe Russia. And then the 3D NFT is going to describe in few sentences about Web3 or decentralization or the country called Russia. You can ask the 3D NFT what is your name, and then the 3D NFT is going to reply with their name. The next and last additional but not least important capability of our 3D NFTs is the capability of them being displayed, having the capability of being displayed in a way of stereoscopics. What stereoscopics means is that a part of the 3D NFT is going to be displayed in red or reddish colors, and another part of the 3D NFT is going to be displayed in blue or cyan colors. Then you can come to our 3D NFT marketplace website, and now is the time to tell you the name and the URL of this website. It is 3dnft.decentralizedweb.org. 3D NFT is typed in a way of the number 3 followed by the letter D, followed by 3 other letters N, F, and T. And it is typed all together, 3D NFT. Then there is dot, then there are two words typed all together, Decentralized Web. Then there is dot and it ends with org. Once again, 3dnft.decentralizedweb.org. On the top of the main page and every other page, you can see a number of links. One of these links point to links to accessories. When you click on this link, you're going to see that we offer special glasses, and when you order and receive one pair of these glasses, then you are going to see that one lens of these glasses is red, and the other lens of these glasses is blue cyan. Then you can put these glasses on. You can request displaying of the 3D NFT in a way of stereoscopics, and then you're going to see the 3D NFT coming out of the flat two-dimensional computer screen, and you're going to see it in real 3 dimensions. With this said, I'm ending talking about our 3D NFT marketplace, 3D NFT software engine, and I like to tell you a little bit about our 3D NFT marketplace. In our 3D NFT marketplace, we have our own blockchain instance, and by having our own blockchain instance, we do not charge our users gas fees for the deployments of the smart contracts for the non-fungible tokens, and we do not charge our users gas fees for transactions of transfer of ownership from one user to another user. And in addition to this, by having our own blockchain instance, we allow our users to buy and receive proceedings from sale in multiple crypto coins. Currently, the choices include Solana Sol, Polygon Polmatic, Avalanche Avax, and Qcoin, which is a big centralized crypto exchange. They have a coin called KCS. in addition to buying and selling in crypto, we have a second parallel and independent way of buying and selling of 3D NFTs, and it is done entirely in fiat currency. If you are, for example, a user and you come to our 3D NFT marketplace, you browse through the collections, and then you click on one 3D NFT that you want to buy. Then you're going to be presented with a drop-down menu asking you to choose between to pay with one of 4 different crypto coins, and the fifth choice of buying with fiat currency. When you click on the button to advance next, then you're going to present it with a screen where you have to put the number of your debit or credit card, expiration date, and CVC. And when you click on the button to complete this transaction and purchase this 3D NFT, then what is going to happen is there is going to be a transaction and conversion from your national fiat currency, which could be different than US dollar, and this payment is going to be converted to US dollars and deposited in our bank account. Then we're going to follow with the transaction and transfer of the initial ownership from our 3D NFT marketplace to you, and now you become owner of this 3D NFT. You can play with this 3D NFT for a while, and at some point you could put this 3D NFT for sale. You decide on the price that you want to put for purchasing of this 3D NFT. And let's say there's a second user. They come to our 3D NFT marketplace, they browse through the collections of 3D NFTs, and they click and want to purchase in particular the 3D NFT that you put for sale. What is going to happen is they're going to go through the same motions of choosing between 4 different crypto coins and the fifth choice of paying with fiat currency. Let's say they select payment with fiat currency, and then they are going to be presented with a screen where they have to put the number of their debit or credit card, expiration date, CVC, and when you click to complete this transaction and purchase this 3D NFT, there's going to be a transaction and conversion from their national fiat currency to US dollars, and the payment is going to be deposited in our bank account. Then we're going to follow this with transaction and transfer of ownership from you to the second user. Now the second user becomes owner of this 3D NFT. Then we are going to make a transaction and conversion from US dollars to your national fiat currency, and the payment for purchase and sale of this 3 NFT is going to be deposited in your bank account in your fiat currency. With this said, I'm ending talking a bit about this second project, and I like to tell you about the third project which we did release, and we did also do a major software update just yesterday, and This project has currently two artificial intelligence entities, and these AI entities are communicating between each other, and you, the human, is just an observer of this interaction between AI entities. But with this said, I like to tell you the name and the URL of this website of this project. It is ai2ai.decentralizedweb.org. AI to AI is typed in the way of the letter A, followed by the letter I, followed by the number 2, followed by two other letters A and I. And it is all typed all together, AI to AI. Then there is dot, and then there are two words typed all together, decentralized web. And then there is dot, and it ends with org. Once again, AI to AI dot decentralizedweb.org. With this said, I'd like to give you an example of interaction between these two AI entities. For example, the first AI entity, we can assign it a gender of being female. Then we can generate AI avatar image for this female AI entity, and then we could assign a female voice and a specific voice pitch for this female AI entity. Then we could use an AI model, and currently we have 10 different AI models, which include models from like open source models from Meta called Yama, and a model called Mistral, and also we include AI models from the four big AI model providers, namely OpenAI, Anthropic, Google, and xAI. We have two AI models, GPT models from OpenAI. Then we have also two AI models from Anthropic, and two Gemini AI models from Google, and finally two AI models, Grok models from xAI. And finally, for this, like after choosing large language model from one of these 10 models, we could prompt put a prompt for this female AI entity to be very seductive. Then for the second AI entity, let's say this second AI entity has a male AI avatar, and it also has a male avatar image, which we could generate or use an existing avatar image from previous interactions. We can assign it one of 4 different male voices, which are in addition to the 4 female voices, and we could assign a different large language model from one of the 10 different models, and we could put a prompt for this male entity to be very angry. And then we could click on the button to start this interaction and then we could notice and observe this interaction between the female AI entity vocalizing seduction seduction sentences and towards the male entity, and the male entity responding in angry fashion to the female AI entity. And then you could continue observing this interaction going back and forth between the male and female AI entity. And at some point you could stop this interaction, and at this point you could save the transcript of this interaction on your local machine and on your local device, be it laptop computer or the Android device, which could be a phone or a tablet. And also you could, after stopping this interaction, you could share this interaction by posting it on, share the parameters of this interaction by posting it on our website, so that other users could see the parameters of this interaction and see it on the our website, which I did mention the URL, which is once again aa2aa.decentralizedweb.org. With this said, I like to mention finally two other projects which are under development. The first AI project is a token counter project, and this token counter project could count and report the tokens which you, the user, are spending, and this token counter project could provide like daily, weekly, or monthly calculation of the tokens that you are spending by using a specific model. But we're aiming additional capabilities, like for example, if the token counter project could monitor the models and the tokens spent with a specific AI provider, then we could also provide the capability of changing from one model to another model with a specific AI provider, or changing the AI provider entirely and using AI models from a different major AI model provider. With this said, I like to mention the second AI project, which is also under development. And this AI project is recording a sequence of steps that the user is taking on your device, be it your laptop or be it your mobile or tablet device. You can request start of the recording of this sequence, and then go through this sequence, and finally, in the last step, you could specify this last step to be a confirmation step, and then you could end recording of this sequence and label this sequence with a specific name. But what an example of this recording of sequence could be, you could record the sequence of like, for example, buying a food item by going through the website of a specific um, grocery store or multiple grocery stores, and then at the last step after choosing a specific food item, you could manually confirm the payment, and then this purchase of the specific food item is going to be delivered to your um, place of home or your current location. Another example of a sequence is buying tickets for a concert going on at specific dates and times at a specific venue. And another example of a sequence of steps which could be recording is buying an airplane ticket for travel to a specific destination from a specific airline or specific travel sites or multiple airlines, and having one stop or multiple stops at different locations at a specific range of dates and times. With this said, I'm ending this presentation. Thank you for listening. Thank you for viewing. Stay tuned for part 2 of this perfect storm brewing with AI capabilities. And have a nice day, have a nice evening, and goodbye.